Good morning. Today we will talk about biometry in post-keratoconus and post-LASIK vision correction. What is the problem? Patient with previous laser correction is very demanding. They hate glasses. The normal benchmark for IOL power calculation accuracy is about more than 80% within 0.5 diopters. But post-LASIK for myopia give at best 70% accuracy within 0.5. So a more realistic target will be within 1 diopter, not within 0.5 diopter. Here you saw the cornea is monofocal or about monofocal. All powers are within a short scale, but here it is multifocal. So if we adjust the IOL for this part, it will not give very accurate vision for this part and for this part. So it is more difficult and more challenging. There is plenty of ways for calculating post-LASIK biometry. Some are on the mode, some will decline, but there is many ways. Are they all accurate? No. And there is true science in choosing the best formula or the best method. What is the problem? Why it is not accurate? First problem is inaccurate K measurements. Here we are measuring with topography. Topography gives reflection of Maher's on precorneal tear film, and we assume it gives the anterior corneal curvature. It is not accurate in dry eye. Second, we measure the 3 millimeter circle. The 3 millimeter circle, we assume it will give us an idea about the central part, but it is not. It is just assumption. Especially in oblate or prolate cornea like this is flatter than the 3 millimeter, and this one is steeper than the 3 millimeter. So we have false assumption. Last, it has different diameters. In flat cornea, it gives larger diameter. In steep cornea, it measures a smaller diameter. So the first assumption is wrong. So we revert to pentacam or slit scanning readings. Second assumption is that the relation between the anterior corneal surface and the posterior corneal surface is constant, about 82%. This is okay in normal corneas, but in myopia we flatten the anterior surface and leave the posterior surface. In hyperopia, we steepen the anterior surface and leave the posterior surface. And in keratoconus, both of them are steep, but not in proportion. So the assumption is false. We cannot predict the posterior corneal surface according to the anterior corneal surface. Third, how to solve these two points. First way is to use ray tracing. We measure the reflection of light in the anterior surface alone and posterior surface alone. But this gives a false A constant, so we must customize our A constant or use the equivalent K reading done by Holiday. The Gaussian optics still, pentacam uses the two methods, total corneal refractive power and true net power, but it also needs adjustment. Now the IOL Master 700 give an good idea. It check the anterior corneal surface and check the pachymetry of the cornea in each point, and so deduce the posterior corneal surface and revert it to power. And by subtraction the two powers itself, it gives the perfect power of the cornea, which is called total power map display. And there is no need for customization in IOL Master 700. Second trick to solve it is to use the aura. It is not widely available, but it is present. The OptiWave refraction analysis, it uses the refraction of the eye, not the K reading at all. At the end of the surgery, the surgeon can measure the refraction of the eye and so calculate which lens he can put. But it has a fallacies. For example, the eye inflation, the OVD, it can change the refraction and the effective lens position. It is not constant. It does not put into consideration the effective lens position. Third problem, the predicting effective lens position. Usual formulas predict the effective lens position according to the K reading. Okay, if the K reading is flat, so it assumes the K reading is here, the effective lens position is here. If it is steep, it is here. But in post-hyperopic LASIK, if it assumes the IOL is here, so it will give myopic post-operative refraction. And in post-myopic LASIK, it will give hyperopic refraction. And this is so cumbersome for the patient. How to solve it? The usual formulas calculated with K reading and axial length. So it is not applicable in post-refractive. So we revert to the second group, the Higgs L, the Oculix, and Olsen. It put another consideration and measure the true AC depths and try to calculate the effective lens position. And the third group, the EVO, the Hurday 2, and Barrett, measure more parameters to predict the effective lens position and neglect at least partially the K reading, or modify something called the double K formulas. So, which formula? This study compares these formulas. It gives the one Koch-Maroni, Jasamash, Higgs, Barrett, and OCT formula. All of them give very low precision at 0.5, but acceptable within 1 diopter. So it is more realistic target, and better the average of all, or at least the average of the best 3. So what to do? The safest option is to use the Higgs L and Barrett True K. It is not the best accurate, but it is the least outliers, so it is safe. If we use this one, Barrett will give 20.5, Higgs will give 22. Large difference. But if we take the average, 21, this is within 0.5 diopter, and this one within 0.1 diopter. So there is small outliers. In unusual axial length, in Barrett True K, less than 28%, it is very accurate. But larger eyes, Shamas is better, and very large eyes, triple S is better. But thanks God, this is very rare to see with post-LASIK cornea. It is usually with refractive lens exchange or phakic IOLs. This meta-analysis compare all formulas with the Higgs, the most useful one. This shows that Barrett True K, but with history. This is one with history, this one with no history. So, this with history and the OCT and ORA are the most accurate, followed by another methods, and within 1 diopter, the same. The Barrett True K with history, the OCT and the ORA are very useful, and even better than Higgs. So what to do? The first and most used is the IOL calculator at ASCRA's website. We put all we have data from Pentacam, from Galili, from whatever, from axial lens, whatever, and even if we have history, and the calculator calculate with history and without history, and give the minimum, the maximum, and the average. It is very useful and commonly used. But another better, I think, the APASCRA's site, not the ASCRA's site, gives a newer version of Barrett True K formula. This 2.5. What is the difference? It is nearly the same, but it has another predicted posterior corneal surface if we use the IOL Master 700 or we use the Pentacam, and even a keratoconus mode. Or we can use the EVO formula. EVO formula is the Hyperopia verification or verifying optical formula. This is another formula, very useful, and it can use the total key reading by 700 if we have it. So, at conclusion, what to use? If you has only ultrasound axial length measurement, don't rely on accuracy, except if you have ORA. If you have IOL Master 500, you can use the built-in Higgs L, and if you have in addition Pentacam or OCT like RTView Avanti, you can use its reading for posterior corneal surface and use the ASCRA's or the ASCRA's formula. Or you can use the online EVO and Kin. These are online and this is built in. If you have IOL Master 700, again you can use the Higgs L and Barrett built in. And if you have Pentacam or total K of 700, you can use the online versions. If you have Laser Star, you can use the Barrett, Jasamash, the Olsen, and the Musket. This is for post-myopic. But what for about hyperopic? All are okay, except the modified mask. Don't use it. Use any other formula. Half a minute. Use any other formula other than the modified masked. For keratoconus, you can use these two formulas. The Kane, it is online, or the Barrett-True at Apascras formula. Okay, it will give very good results. And if you need toric IOL for keratoconus, there is two options. It must be stable and it must agreed with between devices. Use two measures with two devices and give the results. Thank you.